Hey everyone, in this video I want to show you 5 things that I think you should know when using object-oriented programming in Python. Those 5 things are dynamically created classes, the property decorator, magic methods, how to copy objects, and abstract base classes. And before I get into those things, I just want to talk about today's sponsor, Anvil.
Anvil has everything you need to develop and deploy a web app with nothing but Python, and it's free to try. Create your user interface by dragging and dropping components or writing Python code. No JavaScript, CSS, or HTML required. Anvil's web-based editor allows you to develop in your browser, so there's no need to install anything. You can use Anvil's built-in database and let Anvil handle the tricky parts like user authentication, email, and version control. When you're ready, deploy your app to the cloud with only 2 clicks. Check out the link in the description to get started with Anvil today. The first thing I want to show you are dynamically generated classes. So typically we define classes in our code. So for example, I have this application form class and it has a single attribute name and it also has a method validate name. So I'm using Flask WTF, which is just a library for generating forms in Flask. So this name ends up being a field here in this form, and then I could submit it. If I create other attributes, then I have more fields in the form, and this single field is a string field. So for my dynamically generated class example, what I want to do is I want to create a file that will have a list of fields in it, and I want to generate this class dynamically using that file. So the way you do this is with the type function in Python. So normally we think of type as a way to get the type of an item. So if I say type of 5, then it will return int. But I can use type to create a new class, which is also a type, right? So every class that you create is going to be a type. So if I create an object of this application form, that object is going to be of type application form. So the first thing I'll do is I'll recreate this class dynamically. So let me just add it here. And instead of using this existing application form, what I'll do is I'll say application form dynamic is equal to type, right? So this type is going to return a class. So this here application form dynamic is going to be a class. And then this takes in 3 arguments. So the first is the name of the class. So I can just put application form dynamic here again. The second will be this part of the class. So everything that it inherits from as a tuple. So just Flask form in my case. And I need a comma at the end. And then finally, the fields. So this will be a dictionary. The keys will be the name of the fields. So like name or validate name here. And the value will be the actual field itself. So in this case, it can be a string field or it could be a function if we're using methods. So for this particular example, let's just focus on name. What I can do is I can create a dictionary. The key is name. And then the value is going to be string field name, just like that. And then if I instantiate the form application form dynamic, just like this, I should get the exact same thing. So let's take a look. If I just refresh this, I still see name here. Let me rename this to age and just age here so we can see this dynamic form part working. And we have age. All right, so this example is not something you would typically do because this information doesn't come from outside of the program. Dynamic classes work well when you're creating a class based off something that happens outside of the code in a sense. So here I'm just duplicating this form that I have. So let me create an example where I'm bringing in the information from outside. So what I'll do is I'll create a file called fields.txt and I'll just put a couple of fields in there. So name and let's say age. And then what I want to do is I want to open up that file. So with open, and then we have fields.txt as f, and I want to loop over those. So for item and f.read lines, what I want to do is I want to get the field name. So field name equals item.strip to remove any white space. And then I'm going to create a new dictionary. So I'll have fields up here. And fields of field name. Right, so this is the first part, just like age here. And then it's going to be equal to string field and then also the name of the field, right, which is a string. So once I do that, I can take this fields dictionary and put it here. So I'm removing this dictionary and I'm replacing it here. And then when I refresh, I see I get 2 fields. So name and age. And then the fields, if I want to add another one, we'll say occupation. I can add it to this text file here, and then the form should automatically update because the class is dynamic. And of course, I can do a similar thing with methods. So let me just show you that. If I wanted to make sure that it's 10 characters, I can do something like this. So I'll create a function called validate length, takes in self and field, right? So this is a function, but it's going to be used as a method. So I'm going to use self here like it is a method already. And I can just say if length of field.data is greater than 10, I can raise this validation error. And then for the fields here, what I can do is I can say the name will be validate. So it needs to start with validate for this to work. So validate underscore and then plus the field name. And this is going to equal validate length, the function. And then if I run this and I just type in a bunch of characters that are longer than 10 and I submit, this should be validation error instead of validator error, but it should still work once this is done. So I do something longer than 10 characters, submit it, and then we see here field must be less than 10 characters for all 3 fields. So that's an example of how you can use dynamic forms. Kind of rare to use them, but this is one way you can use them when you want to get data from outside of the app to create one of the classes that will be used somewhere inside of your app or your script. Next, I want to talk about properties within classes. So properties allow you to access the getting and setting of particular things in your class or your objects that are based off of a class. So for example, here I have this distance class, and what I'll do is I'll just instantiate a length. So let's say 10 meters equals distance, and then I need to pass in a length for this, so 10, and then the unit will be m. So basically it just stores either meters or feet. Well, it can take meters or feet and convert it to meters. And then for the getting and setting part, I can say something like this. So print 10 meters dot underscore meters, and I'll get to the underscore in a moment. So let me just run this script, and we see I get 10. And then I can basically do the same thing, and before that, I'll update it. So 10 meters underscore meters equals 20. Right? So I do this and it goes from 10 to 20. So this is pretty typical. So I'm basically getting and setting this underscore meters attribute. Well, the reason why I use the underscore is because I don't want it to be an attribute that you can set outside of the class. There's nothing in Python to enforce this, but I just want to make sure that no one can set this outside of the class. So what I'm going to do is I'm going to use the property decorator, and this will allow me to create my own getters and setters so I can make the class work in the way that I want it to work. So I'll show you an example. If I use property here, if I want the user of the class to be able to get the meters, what I can do is I can define a method and then use the name that I want to be after the dot here. So in this case, meters as the name of the method, and then self, and then I can just return what I want. So self underscore meters, right? So now if I do this and I remove the underscore, we see that it still works, but I'm still updating this underscore meters directly. So what I can do is I can create a setter. So what I can do is I can take the name of the property here, the name of the method, and I can use meters dot and then setter. So once this has a property on it, you can then take the name of it and use it as a decorator and then have dot setter after it. And then you can give this a name. It can be the exact same name as you had before. So meters. And then this time I'm taking in a value. So meters, self, and length. And what I want to do is I want to set that internal underscore meters equal to the length. So now if I remove this underscore and I do this again, it works. Okay, so far this isn't very interesting because I'm just using meters twice. But the reason why I did this is because I want to be able to keep track of the length, but the units can change depending on what the user wants. So the class or the object itself will always keep track of a length and a standard unit, which is meters. But if I want to use other units, I can. So let's create another property, and this one will be for feet. So what I want to do for feet is I want to convert my meters, so self underscore meters, to feet. So to do that, I'm going to multiply by 3.28084. And now if I do this, feet and feet, we'll see it changes. So now we have about 32 feet in 10 meters and then 65 feet in 20 meters since we're still setting it here. And if I want to set this in feet, so feet here and length, what I need to do is I need to convert this to meters. So I'll take the length and I'll multiply it by 0.3048, and that will convert it to feet. And now if I want to be able to set the feet, what I'll do is I'll use the name as a decorator. So feet.setter. And then I'll define feet, self length. And then what I'll do is I'll use that internal meters that I have. I'll take the length that's passed in and I'll multiply it by 0.03048. And this will convert it to meters, right? So if I change this to feet, here I'm going to display the distance in feet. So it starts off as 10 meters. I'm going to display the feet. Then I'm going to change it to 20 feet and we'll see. So here we have 32. And then for the second one, we have 20 point and then a bunch of zeros because it's not exact. So I could do some rounding, but at least you can see here that some converting is going on. So first I convert it to meters, and then I'm converting it back to feet to show you. So if you want to take more control over your getters and setters, you should look into using the property decorator more. Next thing I want to show you are magic methods. So the magic methods are the methods inside of a class that begin and end with 2 underscores. So dunder, init, for example, and there are other ones that you've probably have seen, but you may have not realized like what's going on. So these dunder methods, these magic methods, give you the ability to add extra functionality to your classes that make it really easy to work with them in Python using native Python features. So for example, if you want to add 2 things together, so let's say you want to add 2 distances together, you can simply use the plus operator in Python, just like you're adding like 2 numbers, like 3 plus 5. You can take 2 distance objects and add them together with a plus. So what I'll do is I'll set this up. I can say 5 meters equals distance 5 meters, right? And then I can have like 10 meters equals distance 10 m. So I have these 2 objects, and what I want to do is I want to add them together like this. And I want to get the result. So this should be 15 meters. And I want to print 15 meters dot meters. So right now this doesn't work because I can't add these 2 together, but with magic methods I can. So to make this work, the magic method in this case is dunder add. So I define it here. So 2 underscores add and then 2 more underscores and self. And then it takes in a second argument. So the left-hand side you can think of as the object in question, and the right-hand side is the thing that is being added to, right? So I'll just call this other, the other item. And then what I want to do is I want to check to make sure that that other thing is a distance object. So I can say if is instance other distance. So if other is a distance object, then what I want to do is I want to return a new distance object that is the sum of the 2. So self._meters, because the left-hand side is the object in question, plus the other one underscore meters. And then I need the unit again like that. So now when I save this and run it, I get 15 for the meters. If I change this to like 12, I get 17. And there are other magic methods too. Here's a list of them that you can take a look at, but they do so many things that help you with the built-in Python functionality. So I suggest you look at all of them to see what would be useful in your projects. I'll add one more, dunder stir, probably have seen this one. And this allows you to return a string for your object anytime you use something that converts that object to a string, like the print function. So I'll return, let's say, an f string with self._meters and then meters, something like this. So I need to put the closing bracket here, just like that. And now when I print out this 15 meters, which should be 17 right now, I get 17 meters. There's an extra space in there, so I'll just remove that. And we see 17 meters. So this allows you to change how this is displayed anytime you use something that will convert it to a string. And like I said, just take a look at the other magic methods so you can see what's possible when you're working with your classes. Next, I want to talk about copying one of your objects. So what I'll do at the top here is I'll import copy. And copy is a module that has 2 functions in it. So one is just copy again, and the other is deep copy. So these will allow me to create copies of any objects that I create. So typically, if you want to copy an object, so what I'll do is I'll create this 10 meters, and I'll create copy of 10 meters, right? And the simple way of making a copy would be something like this, right? So then if I print 10 meters and I print copy of 10 meters, we would expect these to be exactly the same, which they are. However, if I were to modify a copy of 10 meters, and let's say meters equals 20, and then print them again, let's see what happens. So I get 10 meters for the first two print functions, and then I get 20 and 20. So I only modify the copy, but both of them have been changed. And the reason why is because I'm not actually making a copy when I do this assignment. I'm just making them point to the same place in memory. So if I change one, I'm changing the other automatically. So if I want something that is a clone of an object that I have, and I don't want it to affect the original, I have to use copy. So what I'll do is instead of copy of 10 meters just equals 10 meters, what I'll do is I'll do copy, and then 10 meters like this. And now when I run it, we see 10, 10, 10, 20, right? So 10, 10 are the first two. Then I modify the copy to be 20. Then I print the original again, which is still 10. And then I print the copy. And if you have a more complicated class, instead of using copy, you can use deep copy. So if some of the attributes in your class have like other objects themselves, then you want to use deep copy and it does the same thing. So if you don't need deep copy, then just use copy because copy is faster. But if you do need deep copy, then you can use deep copy, but it's just going to be a little bit slower. So just keep that in mind if you have an object within objects, basically. The last thing I want to talk about are abstract classes and abstract methods within those classes. So oftentimes when we write code, we actually want to write more code to make it easier to keep us from making errors. So test-driven development is one example. You write a bunch of code for your tests, and this just verifies that your code is working like you expect. So abstract methods and abstract classes are along the same line. Like you write more code so the interpreter can help you when you make an error. So in this example, let's think about a game, and in this game, you have a bunch of enemies, right? So these are going to be instances of an enemy class. And we want all these enemy classes to have like an attack method and a get health method, right? So you're going to have different enemies and they all need to have attack and get health. But we also want to make sure that anyone who implements these enemies, that they're forced to use these methods, right? So how can we do that? We can use abstract classes for this. So to use abstract classes, what I'm going to do is I'm going to import from ABC. So ABC is just abstract base class. So import ABC capital and abstract method. And then what I want to do is I want to create a parent enemy class enemy. And this needs to inherit from ABC, right? So this makes it an abstract base class. And then I need to use the abstract method as a decorator. So abstract method on any methods that I want to appear in any children that inherit from enemy. So in this case, I'm going to have an attack, and I'll just pass. I don't have to actually define it here. I'm just saying that this method has to be there. And then abstract method, get health, pass. So now let's see what happens if I try to create an enemy directly. So enemy equals enemy like this. And then I just run this example. So here it says I can't instantiate abstract class enemy with abstract methods attack, get health, right? So I can't create this enemy class. So this class cannot be used directly. It is meant to be used in other classes. So if I create an enemy, let's say a monster, and I inherit from this, then what I want to do is, let's just say pass for now. And what I'll do is I'll instantiate this monster, and we'll see what happens, right? So once again, I can't do this without implementing attack and get health. So let's go ahead and do that. So let me implement attack and just print attacking, and then get health as well. And I'll just print, let's just say 100, health 100. So now when I do this, I get no errors because I've implemented these two. So you may think like, why would I do something like this? Like this is pretty simple. Well, imagine if you had multiple enemies spread throughout your code and you want them to behave in the same way. You want them to have the same main methods. If you didn't do this and someone who implemented a monster didn't create one of these methods, for example, then you have issues that would be hard to debug because you don't exactly know where the error is coming from. Like, this won't give you an error when you first try to run your script. This will only error out as your script is running. It will error out at runtime. So this basically prevents that from happening by making sure that every single class that inherits from enemy has these particular methods implemented. And it's just a way to make sure everything is working correctly. So when you go to run your app or your game or whatever, that's just one less thing you have to worry about. So those are the 5 things that I want to show you in this video. If you have any questions about any of the 5, just let me know in the comments below. If you think there's something else interesting in Python object-oriented programming that I should cover, you can let me know in the comments down below as well. So if you like this video, please give me a thumbs up. And if you haven't subscribed to my channel already, please subscribe. Thank you for watching, and I will talk to you next time.